What is direct variation? What is inverse variation? These are two questions we will answer in this video. So what is direct variation? Suppose we have two quantities. If one of the quantities increases, then the other increases. Or if one of the quantities decreases, then the other decreases. The two quantities are directly related. This is called direct variation. Here are some examples of direct variation. As the level of our comprehension increases, the chance of our success on the exam also increases. As the amount of food we consume increases, the chance of becoming full increases. As the amount of practice decreases, the chance of reaching perfection also decreases. And as the amount of temptation decreases, the chance of being tempted decreases. The hydraulic press is an example of direct variation, because as the force on the small piston increases, the force on the large piston is also affected and vice versa. The formula for the mechanical advantage of a hydraulic press relates the force from the large piston to the force from the small piston. And here is that formula. Here's a hydraulic press problem. When a force of 160 pounds is applied to the small piston of a hydraulic press, a force of 4,800 pounds is exerted by the large piston. Find its mechanical advantage. Here's a diagram for the problem. If we substitute the values for the two forces into the mechanical advantage formula, we can find that the mechanical advantage is 30-1. And now we know what direct variation is. So what is inverse variation? Suppose we have two quantities. If one of the quantities increases, then the other decreases. Or if one of the quantities decreases, then the other increases. The two quantities are inversely related. This is called inverse variation. Here are some examples of inverse variation. As the amount of money we spend increases, the amount of money we save decreases. As the amount of our sleep decreases, our chance of feeling tired increases. The principle of a lever is an example of inverse variation. Consider the formula that expresses the principal relationship. Force 1 times distance 1 equals force 2 times distance 2. If we solve this formula for one of the variables, for example, force 1, we would get force 1 equals force 2 times distance 2 divided by distance 1. Considering the formula in this form, we can see that whenever the value of distance 1 increases, the value of force 1 will decrease. And whenever the value of distance 1 decreases, the value of force 1 will increase. Thus, they are inversely related. Here's a lever problem. A lever is in balance when a mass of 2,000 grams is placed 28 centimeters from a fulcrum. An unknown mass is placed 20 centimeters from the fulcrum on the other side. What is the amount of the unknown mass? So here's a diagram of our problem. We are given force 1 equals 2,000 grams, distance 1 equals 28 centimeters, and distance 2 equals 20 centimeters. We can substitute these values into the lever principal relationship formula, solved for F2, and simplify to find the amount of the unknown mass. So if we do that, we'll find that the second force, or the amount of the unknown mass, is 2,800 grams. So now we know what direct and inverse variation.